In our last example, here's an application problem. It says the formula for the distance traveled by falling objects on the moon is given by the equation d of t equals 2.7 t squared, where d of t is the distance in feet and t is the time in seconds. Find and interpret the average rate of change for an object for 1 to 2. In other words, we're going to kind of do the same thing we just got done doing. So I'm going to find f of 2. So it'll be 2.7 times 2 squared. Well, that's 2.7 times 4. And 2.7 times 4, I get 10.8. Now I'm going to turn around and I'm going to find f of 1. The nice thing about f of 1, that's just 2.7 times 1 squared, which is 2.7 times 1, which is 2.7. Now I'll find the average rate of change. So I'm going to say f of 2 minus f of 1 all over 2 minus 1. So I'm going to say 10.8 minus 2.7 all over 2 minus 1. So in other words, I take 10.8 minus 2.7. And what do we get here? 8 minus 7 is 1. 10 minus 2 is 8. So I get 8.1 over 1. Okay, that's my average rate of change, we'll say is 8.1. Now, interpret that. Interpret really means include the units. So notice, average rate of change, I'm comparing my d of t is feet, and my time is seconds, so it's feet per second. So I'd say it's changing, it's rising because it's positive. So I would say the distance traveled, or the average distance traveled, because we're finding rate of change, is 8.1, and I'm going to rewrite that, that looks sick, 8.1 feet per second, because I have to include my units. That's the important thing. 8.1 feet per second. I like you to write in a complete sentence for application problems. I demand that you include the units. So in other words, please write in a complete sentence, and I'll take points off or count it wrong if you don't include the units. So you have to include the units in questions like this.